Hello everyone. Today I will be presenting a lab on serverless machine learning deployment using AWS. In this session, we will explore how to integrate a trained machine learning model with serverless services to build a scalable real-time prediction API. In this lab, we moved beyond just training and deploying a model. We focused on how to make a machine learning model accessible through a real world application interface using serverless architecture. The goal was to enable real time prediction while minimizing infrastructure management. The main objective of this lab were first to connect the deployed SageMaker endpoint to AWS Lambda. Second, to create a REST API using API Gateway. Third, to enable real-time model interface. And finally, to understand how serverless architecture improves scalability and efficiency. In this lab, we used several AWS services. Amazon SageMaker to host the trained machine learning model. AWS Lambda to process incoming API request and call the model endpoint. Amazon API Gateway to expose the model as a REST API. Amazon CloudWatch to monitor logs and performance. AWS Identity and Access Management to securely manage permissions. Together, these services created a fully functional serverless machine learning system. This slide shows the system architecture. The user sends a request to API Gateway. The API Gateway triggers a Lambda function. The Lambda function processes the input and invokes the SageMaker endpoint. The model generates a prediction and sends it back through Lambda and API Gateway to the user. This design allows automatic scaling and eliminates server management. Lambda function implementation. In this step, we created a Lambda function to act as the bridge between the API and the model. The function parsed incoming JSON data, formatted it correctly for the model, called the SageMaker endpoint using the AWS SDK, returned the prediction as a response. This ensured smooth communication between services. Security was an important part of this lab, so we created an execution role for Lambda and attached permission to invoke the SageMaker endpoint, write logs to CloudWatch. We followed the principle of least privilege to ensure secure access. API Gateway Setup. Next, we created a REST API using API Gateway. We defined a post method, integrated it with the Lambda function, deployed the API to a stage. After deployment, we received a public endpoint URL that allowed user to send prediction requests. Testing the API. To verify the system, we tested the API using tools like Postman. We sent sample input data in JSON format. The API successfully returned prediction result. We also checked CloudWatch logs to ensure the system was functioning correctly. This confirmed that real-time interface was working. Benefits of serverless machine learning. There are several advantages of this approach. No server management, automatic scaling, pay-per-use pricing, easy integration into application, high availability. This makes serverless machine learning ideal for a modern cloud-based system. We faced a few challenges during the lab. One issue was input formatting errors. This was solved by adding validation inside the Lambda function. Another issue was cold start latency. We minimized this by optimizing memory allocation. We also corrected IAM permissions when excess error occurred. Key takeaways. To summarize, serverless architecture simplifies machine learning deployment. Lambda enables scalable interface. API gateway provides secure access, and combining SageMaker with serverless services creates a production-ready machine learning system. In conclusion, this lab demonstrated how to integrate multiple AWS services to deploy a scalable machine learning API. By using a serverless approach, we reduced operational complexity while maintaining performance and scalability. Thank you for your time. I'm happy to answer your questions. If you have any question, leave in the comment section. Thanks for watching.